Hello everyone, my name is Lei, and I joined iExec in the beginning of 2018, and I work as a research engineer on security of blockchain and cloud computing. Today I will talk about an exciting technology which names Intel SGX, and I will show you how can it be employed in our iExec ecosystem to increase security on cloud computing, especially at the application level. Firstly, I will give you a brief introduction to this technology, Intel SGX. Then I will show you some examples that how SGX technology can be employed in iExec platform, which allows protecting the application that is running on a remote system. So SGX, what is SGX? SGX means the Intel Software Guard extensions. It's a set of CPU instruction codes from Intel that allows user-level code to allocate private region of memory called enclaves that are protected from processes running at high privilege levels. It's a security technology available since autumn 2015, which is based on the recent Intel CPU since the architecture Skylake. If you buy your computer after 2015, for most cases, your machine is SGX enabled. Intel SGX employs some security mechanisms which are based on the encryption keys that are fused inside the CPU during the production, and no one is able to inspect this key, including the manufacturer Intel. So it's really just like a top secret that no one can see it. The security brought by SGX technology is guaranteed at the hardware level, which leaves very small attack interface for the attacker. We know that it's relatively easy to crack, for example, at the application level, and it's kind of bit more difficult to crack at the system level. And here, with the SGX technology, since the secret key is protected inside the CPU, so it's really difficult to crack at the hardware CPU level. It's nearly impossible to crack that. In SGX ecosystem, it's mainly used to guarantee the security for executing the cloud applications. SGX make it possible for the first time to use Intel CPU to securely run a application on a remote system. Okay, SGX is great. Let me show you how this technology is employed in our iExec ecosystem. Firstly, let me show you very briefly our iExec platform. So basically, iExec relies on Ethereum blockchain and allows to build a virtual cloud infrastructure that provides high performance computing services on demand. We know that blockchain is great. The Ethereum is great. It allows program to write smart contracts, and the smart contract code is running on the blockchain virtual machine. But we know that blockchains offers very limited computing capacity to run applications, right? That normally few kilobytes of storage. The virtual machine is not efficient and very high latency protocol involved. So our platforms aims to solve these issues by building a distributed cloud infrastructure that is dedicated to support the emerging class of blockchain-based distributed applications. That means these complicated applications cannot run on smart contract due to the blockchain limits, but we can run them on the blockchain-based distributed cloud. And of course, you can read much more details about iExec platform on our website, which is iex.ec. So this video is not here to talk about the iExec platform details. Let's focus on how we can employ the Intel SGX technology to this iExec platform. So basically, SGX is employed to protect the off-chain applications that are running on the remote nodes, remote server. Here we call the remote server, here the workers here. So uh, um, with SGX technology, we can guarantee that when a SGX enabled application is running on the workers here, we can guarantee that worker cannot alter and modify a SGX enabled application. So this is about guarantee the integrity of the application. Secondly, when a SGX enabled application runs on the worker, and the worker can only process encrypted data related to this application. And this encrypted data can only be decrypted inside the CPU. So the application is not accessible by an attacker even it has a root privilege on the workers. Thirdly, since SGX application data is encrypted in the memory by the keys derived from the CPU key, so no one is able to steal secrets by reading and inspecting the memory of the running applications. The SGX is packaged by the SCORM technology, which is a secure Linux container, and is deployed in our platform to protect the remote applications. Now let's focus on some examples to show you how we integrate SCORM SGX technology into our platform to protect the application that is running on a worker, on a remote system. So the first example is very simple. We just build application and put it into SGX Enclave. So SGX Enclave is a protected area where all the data is encrypted and protected. So here, let's show a very simple examples, which is written in language C. So it's a program which called factory.c. So this program just allows to calculate factory based on a input number. So we can build this application with SGX and run it in the SGX enclave. We can, for example, we can run a script which names static building, right? And this script allows to compile, build this application with SGX. So we can just run it. SCORM version equal 1. So version equals 1, that means we will enable the output of this application when the application is running. So we have the factory, okay, with static, with input number 5. So we can see here the SCORM mode equals hardware. That means that this application is correctly runs in a Intel SGX enclave. So this is a very simple example, and if you want to build an example or service with a lot of dependency, so you might be interested in using Docker, so which allows to package everything, package every dependency in a containers. Here we can use another script which allows to build the application with SGX and build a Docker image which package all the dependency. So we can here is a script we named it Docker build. So basically this is a very short script which uses this cross-compile containers to build applications and which can be run inside a Docker image. So let's just build it. And it builds these applications with SGX and inside the doc images. So we can see that the application is inside the folder which is called app. So we can just run it with mode, which HW means hardware. That means that application is run inside the Intel SGX enclave. Equals 1 and SCORM version equals 1 to enable the loggers. We can run this application app factory with input number 5. So we can see the factorial result is 120. So when application runs in this SGX enclave, so the data is encrypted by the CPU derived key. So no one is able to steal secrets by reading the memory of the running applications. Oh, here, sorry, I just mistyped. See here the SCORM, so that's why we did not see the logs here. So here we have the SCORM mode equals hardware. That means the application correctly runs inside the SGX enclave. So here, this example is very simple, and indeed, maybe it may not require some security protection since there's no sensitive data running in these applications. But think of some applications running at the remote server, such like password management service or some application that needs some secret data from users. How we can protect these applications that needs um, um, how we can protect these application secrets from the attacker who may have the root privilege of the remote systems. So, okay, let's move to the second example. So we just exit. Okay, so in the second example, we will show you by integrating this SCORM SGX technology in our iExec platform, we're able to guarantee that the attacker having the root privilege of the remote system can neither inspect nor modify users' application and the data. So basically, here there's the example, which is inside the iExec source code. So let's see this is a very simple example programmed in Python. Which calculates a factorial of a number and hash with a secret sort that is saved in another file named sort here. So firstly, let's try to run it. For example, we have Python with a factory with number 5. So we can see that factory result is 120, and we can hash the result which the sort a secret sort which is saved in the file which is also named sort. Okay, so basically if we want run such applications on remote system for example in the iExec workers, we definitely do not want the remote server to see our codes as well as the secret data. For example, this file sort, which helps to calculate the hash result. And it's not a good idea just to build a secret into a binary because it increases the dependency and it's just not secure. So our solution is based on the SCORM SGX technology. We can encrypt all the secret data, and as soon as this application starts running at the remote server, the encryption key can be transferred to the SGX application via the SGX secure channel within CPU bound, so which means a security channel which is much safer than the legacy security channel like SSH or TLS. Okay, so in order to expose these secrets in order not to expose the secrets at the remote server, we encrypt the application data, and we encrypt the Python application as well as the secret data. For example, is the sort, and we generate a doc image that is to be run on the remote server. So here, imagine that we are at the remote server now. So we are we are at the we are on the worker. Okay, so we can pull the doc image that we just built with the data encrypted. So we can have sudo docker run with the image. We call it iExec, sorry, SGX test, and with the tag we call it factorial hash. Okay, so this is the image that we have built with the application data encrypted. So firstly, let's check the code of the let's check the application and the sort file, and to check that this file is indeed encrypted. So we see it's in the iExec app folder. We can try to see this factory dot py. So you can see that this file is encrypted. And the sort file is also encrypted here. That means the remote server cannot inspect the code and the secrets sent by the users. But we can, at the remote server, we can just try to run it. So we go to the scone. We can assign with some memory heaps. Scone. Always with the scone mode to the hardware mode, and then we try to run this application. So this is factory with an import number. Oh. Can't open file, no such factory. So okay, so we just put iExec applications. So we can see that the application is correctly run inside the Intel SGX enclaves. We can check again for this file. We just run. This file is correct, is encrypted. So just check this file. You see, the code is encrypted, but we can correctly run these applications. And let's do something tricky. Imagine an attacker who had the root privilege at the remote system tries to modify some data sent by the remote users. So let's try to modify this file sort. For example, we try to modify it sort, and it will be finished by end of file. So we can modify, for example, sort the modified and end of file. Okay, so now let's rerun these applications. So we can see, oh, the IO errors. So authentication decryption of block 1 failed, block 0 failed. So we have errors when running these applications. That means SGX can detect that the code or the data is modified, so it just stops the execution of the applications. So we can see that an attacker, even having the root privilege on the remote system is not able to inspect the encrypted application data and is not able to modify the application data. All it can do is just run the applications, so which is expected by the remote user. So, well, in this video, I present you briefly the Intel SGX technology and how can it be employed in our iExec ecosystem to protect the cloud applications running on a remote worker. So we are very proud to announce that we are the first to employ this amazing SGX technology in blockchain-based cloud computing. And we are also working hard to extend this technology to cover more use cases and better protect different components of our iExec ecosystems. Okay, thanks for your time.